Hello, my name is Vishal and I'm from the Cloud Computing Graduate Certificate Program from Humber College for the batch of summer 2024. This is our capstone sponsor, Oracle Lens, and this is the blockchain app final report. So regarding our project, this is basically a blockchain app where it is used to facilitate transactions within the renewable energy sector, mostly catered towards wind and solar and hydro energy. Over here, our task was to optimize the existing proof of stake on the proof of work algorithm and change it into proof of importance. The purpose of us doing the same thing was because the proof of stake or the proof of work has a connotation of vulnerable security, because any new user throwing very high GPU resources within the system would eventually lead the blockchain to collapse or leaving it void of resources. So what we did here is that we streamlined into the proof of importance, over here adding an additional layer of security, which is the trust factor. Hence, a person using the platform for longer periods of time would be awarded like a credit score, which is higher trust authority score. And if that person is trying to fetch resources within the blockchain, he would be awarded more number of resources because he is a frequent user. This was a heavily research-based project, so I would here dive into the diagrams and the various system architecture designs, the ERD, the whole structure of the application, as well as the flowchart for the algorithm of the proof of importance, which is the consensus mechanism in this case. So as you can see, this is the table of contents, and these are the table of figures. So let's just dive into the sequence diagram. So as you can see here, the sequence diagram, this would give you an overview of the application as to how it functions. So the client would send a transaction node, which would eventually go to the API, which would then forward the transaction to the node within the blockchain, which would be awarded to the user. After that, the transaction would be validated by a validator. In this case, our validator is the Tendermint, which is the consensus mechanism protocol validator. Then from that, the validation result would eventually go to the node. If it is finalized, then the block would be sent to the blockchain state over here, and then the statement of acknowledgement would be sent to the node, eventually updating the transaction status within the API, which would be then sent to the client. As you can see, it is a pretty straightforward diagram here. Alright, okay, so that was the sequence diagram. Now let's dive into the system architecture diagram. This is the chain app. The blockchain is coded in Go, and this is where our main crux of the application would be. And then from the external API, the API requests would be sent. Then using those metrics, it would go to a monitoring service, which would then go to the logging service with the, of course, the updates of the state and the health metric logs. Then as you can see that this chain app is also being contacted by the network layer. It is interacting with this layer as well. This would propagate the transaction, which is it would send it forward. And as I mentioned before, our validators here would be using the consensus participation. So in this case, the validator is Tendermint, and the consensus participation algorithm is the proof of importance. And after the validator validates those requests, the validation results would be sent to the blockchain state, and then it would assign a block validation, eventually propelling the network layer to contact with the chain app. Then using all this blockchain state and all the chain app metrics, which would be sent through the monitoring service, it would all record the transactions over here, and then it would store the transaction in a database. All right, okay, so moving forward, we can see the proof of importance flowchart. Over here, you can see that at the start of the transaction, the monitor node activity would calculate the state, check the state of the transaction, and also take into consideration the trust factor. This is the one thing which we are added, hence the proof of importance. Then after calculating the importance success, it would base the rank on the scores, then select the node block for validation, and after that node block gets validated, it would create the block, broadcast the block to the network. The network nodes would again validate the block, and if the block is valid, it would add it to the blockchain, update the node statistics, and loop back to the monitor activity. If it is not, it would penalize node and return the selection to the block validation, hence sending it to a previous state. And if the blockchain is added, it would end, and after looping back, it would again send it to the monitor node activity system. All right. Okay, so moving forward, just to summarize, we went into the system architecture diagram, we analyzed the whole system, and then we delved into the proof of importance flowchart, which gave us an intuitive idea as to how the node functions as a whole. These are some of the reference papers which we took guidance from. One of the most important reference paper I would suggest is the NEM Foundation one. Over here you can see how the consensus mechanism works in the Algorand blockchain, and from there we went into the proof of importance. As you know, proof of importance is fairly a new technology. There isn't much research material available, but we tried our best and tried implementing the algorithm. All right, so that's about it. Thank you for your time and patience. Hope you have a good day.